Alright, so we're starting Unit 7B, which is about inverse trigonometry, with a warm-up, and you guys should have completed this for homework last night, at least parts A through C. And what I'd like you to do before you watch the rest of this video is to pause the video and check your answers for A through C in your groups, and see if there's anything that you guys have questions on or you're not agreeing on, and have those conversations. So pause the video now. Alright, so now that you guys have checked your answers, hopefully we all agree on what those answers are, and you guys can check your answers with mine and my worked out solutions right here. These worked out solutions are posted on the course website, so you can see my work for each one of these problems. Now these are all review from Unit 7A, dealing with Pythagorean theorem and trigonometric ratios with sine, cosine, tangent, etc. What we want to talk about today is our new idea of inverse trig. And so for part D, it's asking, what is the angle of depression when the wizard looks at the line? So if I were to redraw that picture, we have a picture of where the wizard is up here, we're on the ground, the line is down here. So if I just draw this triangle, we're assuming this is a right angle, and it wants the angle of depression. So remember, angle of depression, you always start at the horizontal, depression goes down, so this is the angle that we're talking about. I'll label that X. We have X degrees. Now, the horizontals are always parallel, so that's also this angle right here. We have that this is 50 feet, and this is 160 feet. And so when you look at what's given, we're trying to find the angle of depression. Well, if I knew this other angle, then I could say the sum of the interior angles of a triangle is 180, I could find it. If I knew what this angle is, I know they're congruent, so I could find the other one. But we don't really have any of that information. So all we're given are the side lengths, and we have a right triangle. So instead, what I want to do right now is set up an equation using a trigonometric ratio with the information I have. So if I'm trying to find x down here in this triangle, knowing that these two x's represent the same value, I see that I have the side opposite and adjacent. So I'm going to set up an equation that is the tangent of x is equal to 50 divided by 160. I have one equation with one unknown. I can solve this equation for x. Now when you were solving equations, we often do inverse operations to solve. And so what that means in this case is when you do inverse, the inverse of tangent is literally called inverse tan, or inverse tangent. The notation looks like this. Tan, and then it looks like an exponent of -1, but it's not really raising it to the negative first power. It's just the notation to represent inverse. So you're going to take the inverse tangent of both sides. And when you do the inverse of an operation, they undo one another, and what you're left with on the left-hand side is just x, and that's equal to, you can write as tangent inverse of 50 divided by 160. Now this is the exact answer, but I want an actual value, right? So I'm going to say x is approximately, and you go and you take your calculator. I'll turn this on. If this is the tangent button, the inverse tangent is right above it. So to access that, I press Shift, inverse tangent, and then I'm going to have parentheses and do my 50 divided by 160. And so what that means is x is approximately 17.3540264. That is an approximate. It actually will go on forever. But it doesn't tell us what to round to. So if we wanted exact, this technically would be the exact answer. But to make it make more sense, let's go ahead and round just to the nearest degree. We'll call x is approximately 17, or what is the angle of depression? The angle of depression is approximately 17 degrees. So that's about 17 degrees there. So we can use inverse trigonometry when we are trying to find the angle measure, and we have to know two of the side lengths. So go ahead and pause the video right now and turn to the next page and see if you can use what I just talked about in order to do example 1. It asks you to find the measures of the angles to the nearest tenth of a degree. So you know that the measure of angle S is 90 degrees. Now try and, if you're looking at R, see what ratio should I use if I have 8 and 12 right here. Go ahead and pause and try and set up a trigonometric ratio just like I did the previous problem. All right, I'm going to talk through these just so you guys get a feel for example 1. And then the rest I'd like you to work on your own and then check your answers with the answer key on the course website. So for this one, if I'm trying to find R, then 8 is opposite and 12 is adjacent. So opposite and adjacent means I would use tangent. So the tangent of r would equal 8 divided by 12. I want the measure of that angle though, so I'm going to do inverse tangent of both sides. And I will get that r, or I should say the measure of angle r, is equal to the inverse tangent of 8 divided by 12. And if I approximate that, I get about 33.7 degrees. So the measure of angle r is about that. Now if I want to find measure of angle q, I can set up a trig ratio as well. I can say tangent of q is equal to 12 over 8, because opposite of q is 12 and adjacent would be 8, and do the exact same thing. Or I could recognize that the sum of the measures of the interior angles of a triangle is 180. So if this is 90, and I know the measure of angle r is 33.7 degrees, then I can do 180 minus 90 is 90. I can do 90 minus 33.7. It gives me 56.3. So the measure of angle Q is approximately 56.3 degrees. So you can do that either way. So you got to remember all the tools in your tool belt. All right, so then if we move on to this one, if I'm looking for the measure of angle G, well, 12 is adjacent to G, and 13 is the hypotenuse. So the measure of, adjacent and hypotenuse would be cosine. So the cosine of angle G would be 12 divided by 13. Or measure of angle G would be equal to the inverse cosine of 12 over 13. And so what I get is the measure of angle G is approximately 22.6 degrees. Again, I could set up a different equation for O. Now 12 is opposite of O, 13 is a hypotenuse, so I would use sine of O is equal to 12 over 13, or I just know that O and G are complementary, meaning they have to add to be 90 because E is already 90, and I would get the measure of angle O is approximately 67.4 degrees. All right, so each of the rest of the problems are applying this inverse trig, all right? So I would like you to try these on your own and then check your answers with the answer key posted on the course website. There are a couple things I do want to say, so let's talk through the directions a little bit. For example 2, I strongly recommend drawing a picture. When it says angle of inclination, that's like saying angle of elevation. Same idea, it's the incline, the angle of elevation. As you scooch down, when it says solve the right triangle, it means find all of the missing angle measures. So here, you're already given some, you can fill those in, and then you have to figure out what are all of the rest. So you might use inverse trig, you might use trig, but you have to use your knowledge of trigonometry and right triangles to fill in the rest, and there's a lot of ways to go about doing that. And then as you flip to the last page, some of these you're going to have to draw pictures. I will say, taking a look at example 5, you will need to pay close attention because 5 is not a right triangle. So you need to figure out how can you create a right triangle and find the missing measures. And so example 5 is going to require a little bit of work, and you have to draw in a segment so that you can create right triangles, because you can only use right triangle trig with right triangles. And then scooching down for example 6. Example 6 requires you to look back on the pirate problem that we did in Unit 7A. So if you want to go back to that note packet, take a look at that, and that should give you the additional information that you need to finish example 6. The answer key is posted on the course website, but I will also show you the answers right now. So you can use this video to check your answers to the rest of these. Here are your answers to example 2 and 3. And then you can also have the answers to the rest of these here. So here are your answers to example 4 and 5. Obviously pause the video if that is something that would be helpful for you to pause and take a look at this. And then example 6 and 7. Now again, here are the answers. I do not want you copying these down. My expectation is that you guys are trying them on your own, checking your answers, and if you get stuck, you can look at the answer key. But even before you do that, I prefer that you work with people in your group and talk with someone else. Because if I were in class today, we would be doing this in class and having people present. All right, so good luck with the rest of this. And tomorrow we'll start law of sines and law of cosines.